And welcome everybody to the Daily Space Weather. We are starting things out looking at the last 24 hours of the closest star here in ionized helium. We've got some coronal mass ejections to cover. We've got plasma filaments. We've got a reverse polarity sunspot. We'll cover it and a lot more here at the Smash News Network, least busted name in news. So here's what's going on. We've got some setting sunspot regions there in the northwest. They pose a very high likelihood for large solar flares. And not surprisingly to our regular viewers, those have been the most active regions in the past 24 hours. By the way, something that we don't typically feature on the channel is difference imagery. Yeah, difference imagery. So this is the running difference based on a 60-minute time frame, and this is great at showing obviously differences. It's subtracting pixels. So this will be something that you may expect to see moving forward, as it does show additional detail. It shows some features that are tough to see without the difference imagery. So that's just 304 angstroms with a 60-minute running difference. We'll go from north to south and show you some higher detailed imagery. You can see some huge plasma filaments there on the northern portion of the solar disk. Some filaments around the center portion of the solar disk. You'll especially see some around the limbs there, known as prominences. It's just a filament that is overlapping the edge of the solar disk. And some filaments in the southern hemisphere as well. I would direct your attention to that sunspot over there on the left of your screen. It did appear reverse polarity. We've got an update on that coming momentarily. So let's take a brief look here at sunspots, as we're wont to do most days. There is yesterday plus today. Sunday, July 23rd, plus Monday, July 24th to date. And we do have a couple new sunspot groups likely to get names here. One down here, and one up here trailing this large sunspot. So we do expect to see at least two new named groups today. A little degradation happening up here. It doesn't reduce the possibility of large solar flares, especially from this setting group, which is showing some evolution. Here's colorized magnetogram for the same time period, yesterday plus today to date. And you may see some evolution happening with this sunspot as well. We will talk all about it in just a moment. Before we look at some more stats and what's going on Earth and so on, we do combine your Earth weather and space weather. We put them together. Please support the channel via our merch. You can find merch links on the home page at smashomash.com, as well as below this video. Our top seller is Don't Pole Vault the Caldera. Folks, this public service message is brought to you at massive personal risk and expense by Smash staff and I. So help us continue to bring you this message by picking up some merch. It's one of the many ways to support the channel. We'll tell you more ways in a minute. By the way, I'm wearing the Do Not Pole Vault the Caldera socks right now. They are quite comfy. And this logo does feature not only the public service message, also our YouTube channel and our homepage, smashomash.com. So tell your friends and foes about that. It is our top seller. So jump on the bandwagon, perhaps get yourself some gear right here in the middle of summer with the Do Not Pole Vault the Caldera products. We've also got an Amazon shop, and we're talking about turmeric today, thanks to our viewer who came up with that idea, putting turmeric in the coffee. I tried it. It tastes pretty gross, but I understand the implications of it, so could be a thing. And if you want to pick up turmeric from our Amazon shop, you can save a bundle by buying bulk spices. Don't buy it in a tiny little jar at the grocery store. Buy a 16-ounce bottle of turmeric for only $12 from our Amazon shop. Links below the video to that. Today's featured product on our Hemp Lucid shop, as we do have multiple paid affiliates. This one is the Stress Stacks So if you don't like the idea of gummies, you can pick up these stress stacks. They are capsules containing lion's mane, nettles, and CBD. And when you take the stress stacks, tilt your head down as they float. It makes it easier to swallow the stress stacks. So check those out. I use the stress gummies. I also have the stress stacks. They are similar products. Links below the video to the Hemp Lucid shop as well. And let's get back to Earth and space. Yeah, Earth and space. So here's what's going on Iceland as new real estate gets closer and closer to that boiling caldera of magma becoming lava. It looks like it's becoming a shield volcano. And it looks like it's about to overflow. What do you think? Let us know in the comments. As far as what else is erupting, White Island has actually, it looks like it's downgraded actually. So that's an image of White Island, the volcano that's north of the North Island of New Zealand. And it has actually decreased in its thermal profile. Its temperature has been cut in half in the past few months. So as far as what else is erupting, Abico is. It's producing a 10,000-foot ash plume. Folks, please do not pole vault the caldera. It could be unhealthful. Suminosejima also erupting, 6,000-foot ash plume there, flight level 060. Flight level, who knows, over Mayan. There is a volcanic ash cloud of unknown size over the Philippines. Semeru also exploding, flight level 140 there over East Java, Indonesia. Again, White Island has seen the temperature decline from 240 degrees Celsius to only 120 degrees Celsius. No ash emissions or eruptive activity has been observed, although it is still venting gas and steam. Nevado del Ruiz, no emissions from it. Sangay and Ecuador exploding, flight level 220. It's a 22,000-foot ash plume. Sabancaya, volcanic ash not identifiable in satellite imagery. Could be cloudy, could be erupting, we're not sure. Also Ubinas, exploding in Peru, flight level 240. It's a 24,000-foot ash plume. Flight level 240 over Peru from Ubinas. As far as earthquake activity, there was a 6-magnitude quake in the past 24 hours. There is the past 90 days in a convenient bar graph form. And it got a little bit less quiet here south of Fiji with a 6-magnitude quake that came in at 2:49 Universal Time this morning. It was at extreme depth there, over 540 kilometers estimated depth. And let's see what else happened in the past 24, seismically speaking. Indonesia had a 5.1. That was at 12:33 Universal Time yesterday. A bunch of quakes there in the western portion of the North American continent. They are all of a magnitude less than 5, so we're not going to cover them. Again, there's that 6.0. That's the largest event over the past 24 hours. 2:49 this morning is when it came in. Estimated depth, 546 kilometers. And then some aftershocks following that 6.0, all at similar depth there, 550 kilometers, 551 kilometers. Those are both 5.0s, and that is where the list ends. Next, getting back to space, here's the past 24 hours in SDO 171 angstroms. I've got some weird interference on the feed there. I've never seen that before. Looks like maybe a radiation strike or maybe a cosmic ray hit on the SDO. Right in there. That's a little different. And let's add a little bit of extra depth here by showing the extended corona and adding 211 angstroms to the SDO 171 angstroms wavelength. Some great detail there for you. And let's get to some more stats. 10.7 centimeter radio flux, currently at 173 solar flux units. Almost the same as yesterday. It's dropped down 1 solar flux unit. There is the current state of affairs. And the sun is right in a little bit of a lull of activity here. Don't expect it to continue. There is indication that there is quite a bit of stuff going on the far side. So some sunspots likely to rise here soon. We'll be keeping you posted as far as that goes. Next, the Space Weather Enthusiast dashboard. And NOAA is forecasting a little bit of geomagnetic unrest tonight. So late tonight Universal Time, expecting geomagnetic unrest for a brief period there. The write-up says no geomagnetic storms expected. But again, KP4 there forecasted by NOAA. Not sure why. Not so sure that's a CME impact, but that's the forecast. So possibilities of aurora tonight. Let's see what else is going on here. The past 4 hours of Earth's magnetic moment from space. Let me bring that back. It's our Geospace Magnetosphere movie. It depicts magnetohydrodynamic pressure, and we've got a pretty homogeneous environment here in the Earth system. It is geomagnetically calm at the moment. In fact, it's so geomagnetically calm that the ground magnetic perturbations map has got some equatorial magnetic pulses. So right there you can see some magnetic pulses coming out of the equator. That's Earth's magnetic moment from the ground. It's depicting nanotesla, which is magnetic flux density. Not magnetohydrodynamic pressure. We are seeing some, again, equatorial pulses there coming out of the eastern Pacific. Besides that, nothing, even that's not really major, folks. Next, the KP index currently at 1. KP1 is the geomagnetically calm condition. The planetary K index, if you're not familiar with it, is an average of global geomagnetism. Solar wind here has been pretty uneventful as well. Quite unremarkable for the past 24 hours. The current conditions are, as far as density and solar wind speed, solar wind density here just below 4 protons per cubic centimeter. Solar wind velocity 426 kilometers per second. Let's move to the GOES magnetometers next. Unremarkable there as well. So no significant impacts in terms of solar wind activity and so forth. It is a pretty chill environment where the GOES 16 and GOES 18's magnetometers are located. Next, our top view ecliptic plane field plot. We do see some South Pole magnetism here showing up around the North Polar region, and a bit of a tug-of-war happening here on the far side. So this North Pole magnetism still not fully left the North Heliographic polar area. We've been showing it lurching down, and it's been taking quite a long time throughout this solar cycle, as that is part of the solar polar field reversal process happening right before your very eyes. You can expect to be in a North Pole current sheet here for the next few hours. However, there is a South Pole current sheet coming. So there is the South Pole current sheet. Earth currently right in the middle of a small North Pole current sheet. The solar plasma is polar. It is oriented to one magnetic field or another. Speaking of magnetic fields, here's our line of sight field plot. That depicts the solar B field in blue, North Polar field in green, South Polar field in red. Grayscale is the photosphere magnetism. You can see a lot of organized magnetic fields there on the solar body, depicted by that gray gong magnetogram, which brings us to coronal holes. Coronal holes are super important in that they show us the solar polar field reversal process. We've got some North Pole and South Pole coronal holes here on the same side of the Earth-facing solar disk. Let's take a look at that by subtracting the 211 angstroms wavelength. Subtracting the 171 and just leaving the 211, I should say. So there's 211. It's the past 24 hours. It is once again from the SDO, the Solar Dynamics Observatory. So these are, let's see, these are North Pole And the rest of these are south pole coronal holes. Sector boundary crossing is right like this. And again, there is another one likely headed this way. We may see some solar wind intensifications here in about 3 days associated with that coronal hole. So there's the scenario for coronal holes, which brings us to sunspots. I think those are kind of important, right? Sunspots, people are counting them. People are spooked of them. People are, I don't know what's going on with it. Again, we're likely to have at least 2 new named groups today. There's one down here, and then there's one up here. And the most likely place for a large solar flare is up in the northwestern limb, just like yesterday. 3380 is becoming less likely to produce a major flare, although it still is close to the limb as well. Let's see, this monitor is showing the most likely spot for a large flare indeed to be this group down here, 3380. And we talked about yesterday how it may be reverse polarity. So let's move on to that here. So here is that sunspot. And you're going to see some umbral growth here on the leading edge of that. Those are south pole umbrae forming there. So it's sort of like unreversed its polarity, so to speak. I mean, let's take a look at the magnetic fields here. So you can see the leading field there is white. That is north pole magnetism. And then you can see a bunch of black colored umbrae forming there. That does increase its probability of producing a large solar flare, by the way. Those are deltas. So there's a perfect example of a sunspot evolving from alpha class, really, to beta gamma delta class, the most likely class to produce a large solar flare. So it sort of rose as a reverse polarity sunspot, but then sort of corrected its polarity, if that makes sense. Here is the full disk view zoomed into the equator. So I'm expecting a new group to be named down here, and this group here should get a name as well. That is a new sunspot group also. So a little increase in the sunspot number before this major group sets. That is the current scenario. And let's move into things like energetic particles and solar flares and so forth. We did have some long duration solar flare events. Ghost proton flux has not seen any spikes. You can see multiple long duration flares, including this C7 and this C8.8 double peak flare. They didn't produce any solar energetic particles. Again, there's the ghost proton flux. And how about if we take a look at at the most active regions here, solar flares and so forth. So there you go. There's the past 24 hours. That's SDO 131 plus 94 angstroms. 2 of the many species of ionized iron covered by SDO. And let me get out of the way here while we zoom in a little bit closer to the equator here. Just to reiterate, the most likely place to see a large solar flare is still probably the northwestern limb, although there is a possibility of a large flare in the southeastern limb. Here's an extreme close-up of the most active portion of the closest star. And before we move on to that stuff, let's take a look at what's going on overhead. So, of course, we encourage our viewers to look up. That's a star chart over Lehigh Valley right now from skyandtelescope.org. And if you're viewing the dusk sky, you'll get a great view of Mercury, Venus, and Mars, especially if you have a low horizon and low light pollution. You might be able to see Mercury, Venus, and Mars, the 3rd and 4th brightest objects in the sky at the moment. And then you'll find the moon up there as well, just after sunset. Next, your forecast. This is your 7-day solar system forecast. That's where things are today. That's where things will be in 1 week. We will have a gibbous waxing moon by then. And next we'll look at coronal mass ejections. So here are yesterday's images. And one of those CMEs may have an earthly directed component. So it launched around 1500 Universal Time yesterday. It was associated with that long duration C-class flare. And I do expect that to have an Earth-directed component. So we can expect that to arrive late in the day on the 26th, early in the day on the 27th. Somewhere around that time frame. I'll say late in the day on the 26th is the best time to expect to see an impact there. It won't be a major one. It's not a super dense CME in the first place. But it does appear to have some of the ejecta headed toward your doorstep. So that's exciting. Some possibilities of some more aurora coming here in the next few days. There is the additional 23 frames from today. Nothing happening there. We'll also take a look at Soho Lasco C2 and C3. And right here is where that CME happened. Right in there. You can see a partial halo there. Keep in mind, Earth is moving in this direction with respect to, the sun rotates that way, and the Earth moves the same way at a slower rate of speed. So a CME missing to the west is more likely to strike Earth than one missing to the east, if that makes sense, because Earth is moving to the west. But here's that CME right there, and it's almost a full halo there, so could see as high as like a KP 6.67 there. I doubt it, but you never know. Fingers crossed for some more aurora at mid-latitudes. We'll let those play through briefly and then show even more information. Here is stereo A as well. Feel free to pause the video on this frame if you're not familiar with the locations of those objects like Bepi, Solar Orbiter, Parker Solar Probe, stereo A in red, stereo B in blue. Here is a paused image. And of course we've paused that because, well, just to verify what we've just said, stereo A showing a halo as well. So CME likely to arrive late in the day on the 26th of July. There's a little uptick in space weather. Let's take a look at our custom coronagraphs. There's a 24-hour video. It shows SDO 193 angstroms, Soho Lasco C2 in red, Soho Lasco C3 in blue. And that CME came from right up here. Again, that C-class flare that happened around 1500 Universal Time yesterday. Here's a closer image of that. And there it goes. Or should I say, here it comes. And we're going to talk filaments here in just a minute. So let's take a look at the El Teide Spain ground-based hydrogen alpha telescope. There is El Teide Spain. And check out the filaments. Filament, filament, prominence, prominence down here, prominence over here. So plenty of capacity for additional CMEs. We'll place the likelihood at about 99% to see more CMEs jumping off today. We'll make sure we cover it. We'll keep you posted here at the Smash News Network, least busted name in news. By the way, if you enjoy the content, don't forget to press like, subscribe, share, etc. Tell your friends and foes about the channel, as YouTube doesn't seem to recommend the most comprehensive daily space weather content in the world. For whatever reason. Who knows? The hashtag systems are broken on all social media sites. And Twitter has rebranded to X because Elon is such a genius. He came up with this brilliant idea that, let's make the everything app. Nobody ever thought of that before, Elon. It's so smart. So Twitter has been rebranded to X. We may have to change our link there. I assume the URL will still be the same. What a great idea. That guy is just so smart, so overratedly smart. And yeah, anyway, SmashOmash.com. You can find our links like the merch shop, the Amazon store, the Hemp Lucid shop, etc. right there on the homepage for your convenience. If you do want to join us on social media, if you want to do stuff like name filaments after living people, do it over on X or Twitter or whatever it's called right now. And by the way, just a little note here about big tech. We are also on Instagram and Threads and all over the internet. Again, follow us on our homepage, SmashOmash.com. Click our links, help us out that way, even if you're unwilling or unable to open your cobweb-encrusted wallet. And here come the past couple of hours here. Oh, before we do that, let's show filaments once again. Yeah, filaments. Here's the past 24 hours, actually. And we've added 193 angstroms to the SDO ionized helium, 304 angstroms to show some great contrast to those filaments. So again, some huge filaments here in the northeast especially. Right up here, that's a big filament for sure. That one might deserve a name. I don't know. Let us know in the comments what you think. We've also got some filaments. This one down here might deserve a name. I don't know. That's up to you to decide, as we empower our viewers to get involved in space weather. Here is the most active region for the past 24 hours. That is where most of the flaring came from. And again, plenty of filaments to produce additional CMEs, coronal mass ejections. By the way, fun fact, folks, we can't put the word coronal in the titles of our videos on YouTube. Why? They'll get instantly demonetized. Is that ridiculous or what? We cannot put the word corona in the titles or they'll be demonetized. Is that ridiculous? It is completely broken. The internet, it has been completely broken. Information itself has been outright destroyed by certain criminal tech organizations who will remain unnamed in this video. So here are the past couple of hours. Remember, folks, misleading investors is still a crime, even if you are living in a banana republic. So here are the past couple of hours. Again, you've got some crown prominence activity happening up here. A little bit of activity. It looks like a CME just jumped off over here. Looks like some plasma instability over here. Looks like some plasma instability over here. So it might look like a lull in activity, but don't worry, folks. It's not going to last. It's not going to last. Because it's predictable. It's entirely predictable, folks. So we look at the sun and we look at the features and we say, this is likely to happen, this is not likely to happen, and our bonus features are likely to happen. Here they come. Charging hazards for satellites are not a thing at the moment. This gives us a little bit of insight into what's going on with things like the electron flux. So, but at the moment, satellites have smooth sailing. Here is the electron flux over the past 3 days, and just in a sort of a nominal range there for that. No big deal, nothing to write home about. And here is the electron flux over the past year. That's the greater than 2 mega electron volt electron flux, sort of in a low to moderate range here. Here's the forecast model from NOAA, expecting flat levels here at the next update. That electron flux is measured at the F layer of the ionosphere right here, one slice of the atmosphere. And here's the vibrational frequency. It's the bridge between Earth and space, the F layer of the ionosphere. Here it is, courtesy of Australian Government Bureau of Meteorology. We show it daily on the channel. You never know when archived data will be relevant. If you want to know what was going on with this a year ago or something like that, go to our Daily Space Weather Videos playlist on YouTube, and you'll be able to find it. So that's what's going on. Here's the anomalygram, anomaly in megahertz from a 30-day median. And nothing exciting happening there that I can tell, at least as far as I currently am aware. Ionosphere here looking pretty normal. It's looking like it's ready for some incoming space weather, folks. What do you think? Anyway, here's the latest image. That's 1045 universal time ionogram and 1045 universal time anomalygram. Total electron content depicts free electrons to about 12,500 miles of altitude. And there is the graphic to explain it. When your GPS satellite has to communicate with your handset, it must communicate from the inner portion of the outer Van Allen belt down to the ground. That requires it to communicate through several areas where there could be free electrons, like the outer plasmasphere, the inner Van Allen belt, the inner plasmasphere, and the ionosphere. This is literally a count, a two-dimensional count of all of those electrons from ground level to about 12,500 miles. It's the total electron content forecast, and it's going to show you the most likely places to see GPS errors. And we're having some significant polar electron content anomalies here, especially south of Oceania, south of the Indian Ocean, south of Africa, and south of the Atlantic. There you can see those major Antarctican electron content anomalies happening there. Some electrons a bit out of place. And if you're expecting major GPS errors and you're navigating, try using Wi-Fi location accuracy. That might help you out. If there are Wi-Fi hotspots, the known locations of those IP addresses can help navigate. Here is total electron content anomaly from the 10-day average, and we are seeing some significant anomalies here. There are some appearing over the south-central U.S., the Caribbean, central Mexico, and off the west coast of the U.S. So that's the scenario there. And we're going to close out the space weather section of the video with the latest high-res images. We'll show you that now non-reverse polarity sunspot. So here is the latest SDO intensitygram, and here's the latest magnetogram. So we'll look at this one. Again, that sunspot has grown some south pole umbrae that are ahead of it. They are to its west, which makes it a non-reverse polarity sunspot. So it was just in the state of growing yesterday, folks. That's what happens when you are so on it. You've got the information. So yeah, so here are some more groups that are setting. Let's take a look at those briefly. This one does have some deltas down here especially. This one up here, it's certainly beta gamma class. I don't think it's beta gamma delta class. No, it's not beta gamma. It's just beta gamma class. Anyway, here's the full disk rock back. Again, we're expecting two new name groups, this one down here and this one up here. Those should be 3381 and 3382 if all goes according to the current status quo. Next, we'll show some meteorology stuff. We've decided to combine the Earth and space weather into the same video for your convenience. And because our views got reduced when we put out more content. Yeah, that makes a lot of sense, right? So we're looking at the hottest place in the world here. It's north of Saudi Arabia. I don't know what country that is. My geography is, I have no idea, but it's not even 120 degrees there. 118 degrees. I think that's about the warmest part of the world right there. There's a north to south flow down here, so that's keeping things a little cooler. But here's some stagnation. 118 degrees is the currently warmest part of the planet. Let's take a look at the coldest part of the planet. Since your lives are controlled by temperature. Yeah, temperature. Oh my God, it's temperature, folks. Temperature, it's controlling your lives and perhaps even your souls. Here's the coldest place in the world, and it is negative 96 degrees Fahrenheit down there, as it is winter in Antarctica. And I suspect it's approaching the coldest time of the year for the entire planet here at the moment. The southern hemisphere winter. Here's what's going on in the Arctic. It's looking a little chilly on Greenland here at the moment. Greenland, it's heating faster than every place else, except in the wintertime. What's going on in central Greenland? Only 11 degrees Fahrenheit there. And that is where there is 5 meters of snow from coast to coast all year round. Anyway, let's switch to our regularly scheduled wind and other meteorological maps. Here is that's depicting surface winds, by the way, along with temperature. So let's just switch to just wind. There's a surface wind scenario as this system loiters. It's looking pretty strong there. Let's get a quick wind check. It's looking pretty beefy, folks. That is a significant 90 mile per hour winds there. How about 92 mile per hour winds? So yeah, that is a legit hurricane, and it's just been hanging out there. Let's take a brief look at the sea surface temperatures, just to give you some idea of what's going on. Not that we really forecast for the Southeast Asian part of the planet, but hey, it's a rare occasion here. So let's take a brief look at sea surface temperatures, and plenty of warm water around there. 86 degree water. Just south of it, 86 degree water. Although it is not anomalously warm. So there's the sea surface temperature anomaly. Let's switch back to the basics. So those are the surface winds of the eastern world. Here are the jet streams. Jet streams of the central world. Still blowing backwards over the northern Indian Ocean and over North Africa. Even parts of the Atlantic here featuring a backward jet stream. Jet stream here blowing east to west. Here are the surface winds. Yes. Yes. Those are the surface winds. Ask Smash staff about that and she'll say yes. Here are the surface winds of the western world. Strong low there off the coast of Argentina, and here are the jet streams. Anticyclone here still chilling over New Mexico. Likely clear skies over that part of the planet. Next, our map from windy.com. We're just showing this is just mean sea level pressure here. And part of the reason this hurricane is so weak is because of all of this high pressure wind shear around it. Saharan dust weakened it, wind shear continues to weaken it, and it's in the process of breaking up. As far as this one goes, that is not in the process of breaking up. It's surrounded by hot water. It's going to hang out there. That is my forecast, at least for the next 24 hours. So here is I'm going to look at clouds and fog here over the Americas. We use the shortwave radiation map to show clouds and fog when it's too dark for the visible satellite. You can use this to determine whether or not you'll have clear skies to view things like the aurora. It's the NASA GOES Interactive Weather Satellite Suite. And here's your smoke forecasts from firesmoke.ca. And it looks like quite a bit of smoke here expected in Toronto, Cleveland, Pittsburgh. There's some major fires up there in northern Canada there. Dag. Some raging infernos happening. It's a hellscape in Canada. So that's your smoke forecast. Please pay attention to the time and date stamps in the lower left corner. Also Quebec, continued fires up there. So here is our weather.gov map. This will show you the weather alerts. If your area has an alert, head to weather.gov and click it Those are too many counties for us to cover in this video. Although, moving forward, we may do major meteorology videos. Air quality alerts there for large portions of Minnesota and Wisconsin especially. So let's take a look at some forecasts. First, we'll show the jet stream. There's your jet stream forecast, and like we said yesterday, that anticyclone is going to move toward the Texas stovepipe and then hang out for a minute. Jet stream will get a little bit incoherent here in the coming days, so you can expect some weird weather patterns. It's not HARP. It's not chemtrails. It's not even contrails. It's not geoengineering. It's not Scope X or any other nonsense like that. It's called the weather. The jet stream typically moves weather systems from west to east, and in a couple days you can expect some oddities happening as convective forces will take over and drive systems in different weird directions. Here is our pressure and precipitation forecast. By the way, that last GIF animation, that was the GFS 72-hour model. This is the GFS 72-hour model for pressure and precipitation. Some heavy storms are coming to northern Minnesota and southern Canada. Last but not least, here's our temperature anomaly forecast in degrees Celsius based on the same model. It is the GFS 72-hour model. Next, your lightning mapper. There is where the strikes have been for the past about 10 hours. And that animation looks jacked up. Let's press refresh here. Sup with that. Sup with that. There we go. That's a little better. And let's see if we have any terrestrial strikes here while we produce the video. There was a little storm here. It's fairly concentrated. And that is northwest of Kansas City. That's Kansas City, Kansas/Missouri. Here's your full world view from lightningmaps.org. By the way, if you enjoy the content, please support the channel. Consider becoming a member of the Smash Team at smashomash.com/Smash Team. Did you know we send out email alerts about things like space weather, tsunamis, things like that? Yeah, it's true. smashomash.com/Smash Team. You can also find the constant Twitch stream, which we run almost all the time there. Sometimes computers crash and we have to restart things, but smashomash.com/Smash Team. We provide all kinds of benefits to especially our gold Smash Team level members. We also do put up additional content posts for silver, and even additional content posts for the bronze level, which will cost you $0 per month if you want email alerts. If you're not getting notifications from certain criminal big tech organizations who do not send you notifications when we put out a video, we diligently send out email alerts about videos just like this one. So why not join the Smash Team, sign up for email alerts, and don't rely on certain criminally negligent organizations to provide you with notifications for the space weather stations. smashomash.com/Smash Team. And if you're unable and or unwilling to help us out financially speaking, to increase the probability these videos will continue to exist, remain publicly visible and free for all to view, press like, press subscribe, press share. How many of you YouTube viewers right now have been viewing the content for years and have never bought any merch, never visited any of our affiliate links, never visited our homepage, never signed up for email alerts, never became a member of the Smash Team, etc.? How many of you out there who watch these videos every day have done exactly nothing besides view the video and that's it? All right, well, we're not offended by that. However, you could always press like, subscribe, and share. You could always leave a comment. And by the way, thanks to everybody who tunes into our daily live premieres. We enjoy watching the videos with our viewers as, folks, I'm not only Smash-O-Mash, I'm also a client. I discovered in the mid-1990s that there's a hole in cosmology, and that hole is heliophysics. I expected all kinds of crazy information coming from college astronomy about heliophysics, and it just didn't happen because, well, it is vastly, misunderstood. Vastly misunderstood. So press like, subscribe, share, etc. Thanks to all of our viewers on YouTube. And let's close this thing out with U.S. Doppler radar map. We'll show the full 50 state view, and then we'll focus on the lower 48 view. Kansas City, you're in the crosshairs. Here is the clouds and fog map. That's once again the 3.9 micrometer infrared radiation, the shortwave radiation map. And here is the water vapor. It looks like clear skies over Louisiana and East Texas, as there is high pressure in that area. And huge pressure gradients forming here as rapid cloud nucleation happens over South Dakota, Nebraska, and then moving down into Missouri. Here's your recap to close this mother out. U.S. Doppler radar shows vertical motion in the air column from ground-based Doppler systems. Here's clouds and fog from space-based systems, showing clouds and fog even when it's too dark for the visible satellite. And last but not least, here is water vapor. When your Doppler looks unclear, try the water vapor map. If you understand atmospheric physics, it will help. Usually when people think that they're seeing all kinds of funky weather phenomenon, it's just because there is a pressure gradient. Yeah, pressure gradients. They're what cause weird weather and all kinds of equilibration of the atmosphere as things in nature want to reach static equilibrium. Anyway, thanks for tuning in to the Smash News Network, least busted name in news. It's about time to get back to the bunker. While I'm gone, may that solar wind be at your back. I'm going back to the bunker again. Whoa!